CCIE is a drops mic certification. Glad to have you and thank you so much. Pleasure. Welcome. Thank you.
Thanks, everyone. It's a good afternoon. No, this is one of the hardest times to present in the afternoon, especially if there's no open bar and guys are not enthusiastic about what's coming next. But yeah, we know the buzzword today has been zero trust. I'm sure even yesterday. So I'll just take you through our interpretation of zero trust, why we think there's a need for it, how we cover it, and maybe some of the products we have to counter that. So the first thing we know is that the way we do business has changed. Someone brought up last year's pandemic. Today, we're looking at a war happening over there in Europe, and that war is also bringing in some cyber security threats, some concerns around the way we're doing business. You're finding like things like the price of gas has gone up. It's not really affecting us, but basically we need to look at how do we adjust for the future, because some of these things we'll never be able to predict. So these are some of the challenges that we are looking at solving with zero trust. The first one is an increased complexity. You'll notice that every time you have maybe a security threat, you'll go and get a tool to mitigate that threat. But then the issue is, do these tools talk to each other? Do your analysts get alerts from these tools, and are they able to remediate quickly? You have an increased attack surface. You have contractors, you have people working from home, you have people bringing in their own devices, you're going to the cloud, you're probably migrating some of your workloads to the cloud, and all that brings around a gap in visibility. So you can't really tell what's happening across all these tools. So we're seeing some of the primary use cases and some of the way our customers are getting into zero trust. First thing, like we're told, zero trust is not a journey, it's a destination. It's not a destination, sorry. It's a journey. It's you constantly plan for it. It's not something that you can actually buy. You don't buy a point product that covers zero trust. So some of the primary use cases are secure remote access, especially with the pandemic last year. How do you make sure that the person who's coming in is the same person you think they are and with a clean device? Secure multi-cloud access. Probably now you have your private cloud set up. You have a few public cloud providers, so you have several vendors in that space. And then how do you mitigate threats? How do you defend against breaches? How can you first identify an indicator of compromise, and then within the same time space, be able to mitigate across that and also increase the speed of response? So this is our approach, and this is what's different in a zero trust approach. So the traditional approach just assumes that as soon as you're into the network, then you can be given access to whatever you need. So the problem with that is that what attackers are in, they're able to just move across your entities, your applications, your workloads, and they're able to go to the crown jewels. So they'll be able to maybe do something like privilege escalation, some shellcode execution, and with that, you realize that the impact is much larger. With a zero trust approach, trust has to be established for every access request, regardless of whether it's coming from outside the network or from inside the network. This has to be done continuously. The advantage with a zero trust approach, so the traditional approach assumes you have a campus where people come in, sit, which used to work back then. But now with the new approach, people are working from home. You have several cloud vendors. You have people bringing in their own devices. You have hybrid setup. So how do you then regulate all that? So this is what Cisco's approach to zero trust is. We have 3 key tenants. The first one is the workforce. The workforce are your users and devices. Maguire showed us 6 entities. So ours are 3 that combine the 6 entities. So the first one is the workforce. These are your users and devices. So you want to make sure that the user is who they say they are and they're coming in with a clean device. The second one is the workload. So when I talk about the workload, these are your applications, your microservices, your VMs, your containers, anything you have running in your data center. And how then do you secure communication across all these applications? Then the last one is the workplace. The workplace is your campus. You want to have that proper segmentation that when a user comes in, they're only assigned access to whatever they need to access, nothing else. And you're able to carry out that segmentation across the entire campus network. And this also applies to your IoT devices. You have to remember that IoT devices can be used by attackers to leverage access to your network. So this is our approach, like I said. So with the workforce, what we're targeting are the people and the devices. So the trust verification is when accessing applications. This does not have to be over VPN or from someone seated in the office. Maybe someone who's on the road and they're trying to access applications remotely. Workloads, these are your applications, like we said, services, microservices, VMs, containers, anything you have running in your data center, bare metal servers, all that. So when they're trying to communicate with other systems, how do you secure that? So your workplace is going to be your IoT devices, people coming in with their laptops, connecting to Wi-Fi, getting access and all that. So this is our portfolio. I'll just go a bit more into detail, so I won't really discuss this right now. This is the reason why you need to enable zero trust. The first bit is you want to prevent risks. You want to make sure that you can validate that the user who is coming in with a clean device. So before you admit someone onto your network, you have some compliance metrics that maybe you want to carry out. You want to make sure that their device has a up-to-date OS, that the critical applications are patched. You want to make sure things like, are they running disk level encryption? Do they have an antivirus turned on, the native antivirus? All that. Do they have an anti-malware setup, antivirus setup? Then the second thing is you want to gain visibility into who is connecting to your network or what applications are connecting to your network and what they are doing. So you want to that full visibility, and that really comes in play, especially when you want to identify risks and better respond to them. You want to be able to first identify these indicators of a breach of trust. Then the third one is reducing your attack surface. Like we said, without segmentation, someone could leverage that access and move laterally across your network and cause all manner of havoc. But right now, with segmentation, what you do is that once that person has, maybe been able to get access to your application or maybe been able to get access to your network, then you limit their impact. They can't really, leverage that to move across the network laterally because your network is set up in such a way that microsegmentation is at the core of it. So these are the Cisco zero trust tenants. The first one is being able to establish trust, establish user and device trust, and establish user and device hygiene. The second one is enforce trust-based access. So with this one, you're looking at the rules of least privilege, making sure that you only access whatever you need to access and nothing more. Then the third one is continuously verifying trust. You may have given someone access to your network, but then they download malware. In that case, you need to limit their access to only the remediation tools that will allow them to remediate this malware and making sure that this is done automatically. You can't have your teams responding to this on the fly. So you want to make sure that these tools can communicate to each other. So this is where we start. So with the workforce, the questions we asked are, is the user who they say they are? Do they have access to the right applications? Is the device they're coming in secure, and is it trusted by the organization? With the workloads, around the workloads, we're asking, what applications are you running in your enterprise? Are you aware of them? What is communicating with these applications? What are their dependencies? Do you have any rules that, control that communication and apply microsegmentation? So is that communication secure and trusted? Then the third one, this is around the workplace. So I'm sure we've all used the network access control. So with this, you just want to make sure that users and devices are authenticated for whatever they need to do. You want to make sure that you just give them access to whatever they need, and you want to make sure that the devices are secure. So I'll just quickly jump through the solutions. I'll spend a bit more time on the workloads because that one is a bit newer. But with the workforce, we've all dealt with the multi-factor authentication tool. So what we have is something that goes above and beyond what a multi-factor authentication tool. Multi-factor authentication tool just protects against things like credential theft, phishing, malware, all that. But do you have something that is able to check for the user's hygiene on the device before admitting them onto the network? And based on that, in case this device is noted to be hosting malware, can you only give them access to a remediation center and not access to everything in your network? So that's how we verify trust for the workforce. First one is verify user's identity. That's where the law of non-repudiation comes in. You want to make sure that this is the person they said they are using multi-factor authentication. Second one is getting device visibility and being able to establish trust with that device. Checking for all those conditions we looked at. Is the OS patched? Are critical applications patched? Is the device running anti-malware, antivirus? Then the third thing is, if the user and the device are clean, then give them access to whatever they need to access. So this is just a use case. I won't go a bit into that because of the time. Let me talk about the workloads. So around the workloads, what we have is a tool called Cisco Secure Workload. And I'll just give you a brief description of how it works. What it does is that it's a very lightweight agent, less than 3% CPU, that you drop onto your workloads. It does not sit inline, doesn't do any fingerprinting, so it's not something that can be identified externally. Once you install it, it's going to give you certain scores. The first one is a secure score, and it's going to look at things like process hashes. Yeah, it's going to look at things like process hash scores. It's going to look at your level of microsegmentation. It's going to run an application dependency map. So it's going to look at what does your application require for it to communicate properly, for it to carry out its function. Based on that, it's going to create automatic policies around your workload. These are workload policies that sit on the workload itself. If it's a Windows workload, it's going to sit on the Windows native firewall. If it's on Linux, it's going to be on the IP tables. And with this, you can move it across. So imagine previously you had a firewall in your data center to do the microsegmentation. Right now, the firewall sits on the workload. You're able to move it across, and with this, you don't get bottlenecks in performance where all the traffic has to pass through a central firewall. So what you're doing around this is you're able to gain visibility into what's running in your data center. Shadow IT, you're able to see everything that's running. You're able to contain breaches and minimize lateral movement because once that application dependency map has been done, you have automated firewall rules that you can now, just enforce quickly, and you're able to alert and block communication if any policy is violated. So the third one is very quickly around the workplace, just making sure that the users are who they say they are, giving them least privilege access control. And how do you do that? Like we said, the first level is just getting the right level of network access to the users and devices. Don't give them full access to anything that they don't need. Just limit their access to whatever they need to carry out their roles. Second thing is being able to classify and segment these users and devices. This also applies for IoT devices. You don't want attackers leveraging access to a printer to then corrupt your network. Then the third one is being able to contain infected endpoints, and this should be done on the go. If an endpoint is infected, automatically it should be taken out the network and just quarantined or set up for remediation. So I think I've just seen sense that my time is up. So yeah, that's around Zero Trust. This is something that's going to be, you're going to hear more and more of it because it's not really a product. It's something that I'd say is an industry term. It came up in 1996, and Google were actually the first ones to implement it with Beyond Corp. So you'll see a lot more of it in the future. Thank you, everyone, and have a nice afternoon.